welcome everybody to this next panel, which is about AI, curriculum and schools and data. So we'll get straight on because I know we've only got half an hour. So if we can bring on the other panelists, that will be super, and I will ask them to introduce themselves. Just quickly about me, my name is Robbie Stamp. I'm interested in governance and ethics around data and AI, and I've always been fundamentally interested in the nature of human judgment and decision making, particularly in complex environments. So that's kind of maybe my vague credentials for being here today. So Michaela, I'm going to come to you first. If you could just introduce yourself.
Great, thank you, Robbie. My name is Michaela Bibby, and I am the producer and the host of the Teens and AI podcast, a podcast made by young adults for other young adults, exploring the world of tech and AI from a young person's perspective. Mm-hmm. I'm also a gap year student going on to combine study across STEM and the social sciences at Harvard University next year. And I'm really excited to be here both as a student who's just come through the UK secondary school system and also as an advocate for educational reform in the UK.
Michaela, Fabi, thanks very much indeed. And we all are loving your map of Paris behind you. Sue.
Hi, Robbie. Thank you very much. So I'm Sue Sentence. I'm the Chief Learning Officer for Raspberry Pi Foundation. That's a charity to support children learning and young people learning computing and digital making. I'm also an academic, and I do research in computing education and how we teach things in an age-appropriate way. And I've been very involved with the computing curriculum since it came into place in England in 2014.
So thank you very much indeed. Conrad.
So I'm Conrad Wolfram. My day job is Chief Executive of Wolfram Research Europe. So we build things like Wolfram Alpha and Mathematica and notebooks and other things that are everything computation. Have done that for about 30 years. My evening job is to try and fix maths education by assuming computers exist. And in a sense, it's two sides of a coin, because I want to make the technology as good as possible to elevate computing as far as I can, and I want to then get humans up to work with that in the optimal way.
Super, Conrad. Thank you very much. So just to give everybody a sort of expectation, what everybody's going to do, we'll be starting off with Conrad, who's got a very few slides to show, and then Sue, and then Michaela. We'll try and do all that sort of opening, the things that people are clear they would like to make sure we try and discuss, and then we'll be trying to get on to the discussion part of things for certainly at least 20 minutes of this half hour. So in order to keep things moving along, Conrad, I'm going to ask you now to share your slides and try and make sure that you do keep absolutely to that time.
So look, I just wanted to open this by saying, when we talk about AI in education, we've got to be very clear. There are two rather different parts to this. One is, what people often talk about, pedagogical improvement on today's subject. But what I think we want to talk about in this panel is improving what you actually learn based on the fact that AI exists in the world. And in a sense, the central question for education going forwards is going to be, what's for the human, what's for the computer? What is it that we as humans have to learn now that we are sharing sort of quintessentially human skill of intelligence with computers? And that will define a lot of the improvements to education. And so another way to ask this is, what are today's survival skills? It's not putting a fire in front of your cave anymore. What is it? What are the top value-added skills that we need for our populations today that's going to drive the UK and other countries forwards to be really doing things that only humans can do? And at the center of this, I think there's computational thinking. The idea that there's a way of thinking about life using computation, using computing, using AI that allows us to go further in making better decisions. And a key question I have is, when you look at our curricula, maths is right at the center of this. It's the core computational subject at the moment. And is it manifesting computational thinking? Is it achieving data literacy and data science? Is it promoting logical thought that we can use? Is it optimizing sort of economic jobs? Is it developing what I would call computational literacy? Ability to understand computation. We've seen in this pandemic various holes in that whole picture as to whether people can understand, even some of our experts promoting, in a sense, predictions that they can't really make. So these are central issues for our societies going forward. Now, key question, what am I talking about here with maths and what's lacking? Maths is really a four-step process. You define the question, you abstract it, very powerful step, to normally what you think of as little mathematical symbols and things. Then you compute between the question you've posed and the answer. That's the sort of magical step. And then you interpret the result. You say, well, x equals 3. What did that mean? Did that answer my question at the beginning? The central problem in our curriculum right now is we're spending almost all our time doing that step 3 by hand. And yet that's the step that we really ought to have computers doing almost all of. That's what they do in the real world. And we ought to have our students doing much, much more with much harder problems of steps 1, 2, and 4. And a key question, a key issue here is, if you remove the computer, you will remove most of the context that mathematics and computing is used for, and computation is used for on the real world. Biology, making vaccines, understanding COVID, climate change, all of these things require mass computation for to be able to use mathematics and computation, and you cannot do them without a computer. So if you want to discuss those sorts of issues, you have to have a computer. There's another issue, which is that you're learning totally the wrong tool sets if you don't do it with a computer. So you end up with, in a sense, the wrong subject, as well as not putting it in context, not getting the experience you really need. How does computational thinking, and I'm talking about maths, coding, fit together? I think there's several ways to look at this, but I think of computational thinking as the general way of thinking about life. Coding is central in that, to be able to write down the abstraction, write down how you are expressing yourself, as well as getting the computer to execute it. And in a sense, maths has a huge domain knowledge of different algorithms that you need to deploy. So these all fit together and should really be part of the same core computational subject. The key point here is this. In education, and it's happened before, but it happens far more prevalently now in our fourth industrial age that we're coming into, in the AI age, as I prefer to call it. When we get new powers of automation, new mechanization, what do you do with it? And my argument is you need to stand on that power and not try to compete with it as a human. So we need to stand on the power of automation that's now available for maths and computation. It's completely the most transformative mechanization in human history. And we need to work a level up from the machines and not compete. We want first-rate human problem solvers, not third-rate human computers. And my full proposal, in a sense, is in the book I've just written, and also the campaign we've launched to try and change the fundamentals of what the curriculum should have in it. Thanks.
Thank you very much, Conrad. It's a great start. And indeed, people who know me know my background with The Hitchhiker's Guide to the Galaxy and The Answer to Life, the Universe, and Everything, which was all about asking the right question in the first place and not getting the answer to 42. So that's asking the right questions. Sue, over to you next. And again, if we can do what we did, thank you very much, Conrad. Keep things moving. That will be grand.
Yes, I'm very interested in what Conrad says. And of course, I come to things from the computing curriculum point of view, and I very much agree that we need to teach and be aware of and develop computational thinking skills. And I think we're very lucky in England because we have a mandatory computing curriculum that's been in place since 2014, and we cover a lot of algorithmic thinking and those sort of skills in that curriculum. But it was written in 2013, so I think there's more we could do to sort of bring that up to date and bring more data literacy and awareness of artificial intelligence and machine learning into that curriculum. But I think we should maybe start from where we are in quite a pragmatic way and think, we're very lucky that we've got computing all the way from 5 years old all the way to 16 as a mandatory subject. That's an equity issue. That means it is accessible to everybody, but maybe there are things we can do sort of bring that up to date. And I think we can corral all the resources that are being developed all around the world for teaching AI to young children. There are lots of things available. The Raspberry Pi Foundation's got resources for Scratch and Python and Wolfram's Mathematica for teaching machine learning, and we should be bringing those into the curriculum or in extracurricular areas. So there's lots of things, we haven't got to start from scratch. There's lots we can do, but what I'm concerned about is that we do that in an age appropriate way, that we work out what we should be teaching in terms of AI and data and machine learning, at what age, what's appropriate, and we balance these things that Michaela might be going to talk about, is around, the societal issues, what we understand about what's going on around us, and the ethics issues, and the technical issues, how we learn the key concepts, and what age we can bring those in. So those are things I'm interested in around what we can do with the current computing curriculum that we have to make it more sort of future ready, more future sensitive, and relevant to young people going into the future that we have for them.
Thank you very much indeed. Fantastic. Michaela, as somebody who's just been through the system which everybody is describing, may be perfect for you to sort of respond and lay out the things that you want to make absolutely sure that we've covered today.
Yeah, definitely. So I think I just want to preface everything I'm going to say by saying that it's so important that we're having this conversation, because I truly believe that we've already let down one generation of students who haven't been adequately equipped with all the skills they need to be working in this tech-centered and AI-centered job market that we're about to go into. And if we don't implement fundamental change soon, we're going to lose more generations. And so we're going to let down more generations. And so there are three key areas that I think are often not included in these conversations about implementing AI and data literacy. And the first thing I think that isn't considered enough is the context and student mindset that we're dealing with. The UK education system is so fundamentally pre-professional and formulaic. You have students at the age of 12 and 13 making decisions and putting themselves into boxes based on what sort of career they want to have, what type of student they are. Are they a humanities student? Are they a more scientific student? And they're making those decisions from a really, really young age. And so we need to really consider that when we think, how do we increase engagement? The second area that we need to look at is why students aren't currently engaging with the existing computer science curriculums as much as we would want them to. And for me, that's due to a couple of key reasons. That's due to the fact that it can be seen as like slightly inaccessible in terms of the fact that we're very much focused on the key coding skills at the moment in our current curriculums, and there's not enough conversation, in my opinion, that brings in a range of different types of students. We need to have conversations about the ethics, about the business side of things, really contextualize what these students are learning in their classes. And I think the second issue for me is the misperception of what it means to work in the tech industry. I think a lot of young adults like myself would say, well, it means sitting behind a computer coding. There's not an understanding about the really multifaceted and interdisciplinary field that tech actually is, and that it will be in the future. And so the third and final area that I really want to bring attention to is the lessons we can therefore learn from why students aren't engaging with the current tech curriculums. And for me, the first lesson that we can learn is that we need to change the perception of the tech industry and what it means to have a career. And that's how we're going to increase engagement in a pre-professional education system. And secondly, and most importantly, all of the the main focus of our curriculum changes needs to be for the youngest students. Picking up on what Sue said, we are so lucky to have that computer science curriculum from such a young age. But if we focus our attention on the 16, 17, 18-year-olds, we've already lost them. They've already made decisions about their career, about what they're going to study at university. And so we need to focus on the junior school students and the year 7 and 8 and increase that engagement and excitement then before we lose them.
Michaela, can I ask you, thank you very much indeed. A point I'd like to pick up that Conrad made there at the beginning, which seems to be a really interesting one, about sort of that, what you're suggesting is all, if you like, the contextual thought that goes around understanding automation and AI, and what AI is going to do, and what humans are going to do, and what that emergent relationship looks like. And given your thoughts about the interdisciplinary, I wonder if you could pick up that point that Conrad made there at the top, because it seems to be quite an important one, which links to a lot of what you're saying about thinking in an interdisciplinary way.
Yeah, so I think, as I've mentioned, in the context of the education system, as forcing students to make these decisions about their careers and what the subject they're taking now are going to ultimately inform them and enable them to do, it's so important that we are helping students understand why computer science, why AI and data literacy is important. And as Conrad said, the maths that we're currently teaching students is outdated, and there's not enough understanding about why artificial intelligence is relevant, why students need to have skills in data literacy, and therefore you're never going to have a high level of engagement and excitement, because if students don't perceive themselves as more of a techie or a code-based person, they're not going to fully engage and be excited by those curriculums. And so in order to engage students from all these different areas that we really want to have engaged in the conversations, we need to bring in conversations about ethics. We need to help them realize that tech is everywhere. It's no longer an optional choice that you can choose not to engage with in your future. It's a fundamental value, and it's a fundamental part of our lives. It's changed the soft skills that we need. It's changed the actual hard skills that we need, and it's completely revolutionized the way that we work and interact.
Thank you. Sue, as a curriculum specialist, what do you see as the key barriers? What are just one or two things fundamentally we could do differently that we're not doing now? If you could wave that wand, what would be, if you were talking to somebody at the DFE, what would be the one or two key things you would say, here's what we really need to stop doing, and here's what we need to start doing? Just one or two. Keep it as sharp as possible.
Okay, thank you. I agree with so much with lots of what Michaela says. But my one comment to Michaela's point is a lot of the making it relevant and making contextualize things is actually in the hands of teachers. So maybe it's, providing looking at what we already teach, the content there, and then making sure that we bring it to life. Do you know what I mean? That we have the right context, we make it relevant. So that's something that we might be able to do already. But the second thing I want to say about the curriculum is I'm quite swayed by the work done by the AI for K-12 group, and they have these 5 big ideas of AI that are perception, representation, learning, like we learn from data, interaction, a bit like Conrad's talking about the human and computers, and then the societal impact. So it's not just all about ethics. We can teach about ethics, bias, fairness, relevance to the world, but we need some sort of content about AI in the curriculum as well. But the issue is, and Robbie wants me to be short and sharp, but the issue is, as a curriculum, in terms of a curriculum designer, if you're going to put more into the curriculum, you've got to take some things out. So some of the things that we learn about how does a barcode reader work or something, I don't think we even learn that anymore, but those kind of awful recall things, they need to be taken out of the curriculum. What does protocol stand for? So that we've got room to bring in the things that are a bit more aligned, not just to the ethics and bias side, but also to the actual, the key foundations of AI and machine learning. I think we owe it to our students to put those into the curriculum in an age-appropriate way.
Thank you. Conrad, your focus is so clear, and it's maybe a slightly very obvious question, but again, reflect why you've started with the maths, which is so important. And as somebody who struggled deeply with maths at school, it's something that I was very refreshed to hear about you contextualizing maths in a different way. So that sort of laser focus you've got, can you just expand on that a little bit more in the light?
Let me be bolder than I've been. Maths that we have right now, which takes up a huge fraction of the curriculum, is probably 80% the wrong subject in schools. It's that bad. It's focused on calculating quadratic equations and things which nobody uses. And what we need to do is start from problems that relate to a student's life and student's life at that moment and going forwards. Use those problems to kick off computational thinking, helping, there are various ways to do that, structuring the curriculum in appropriate ways, things that are very, so to speak, walked through with teachers, things that are more project-based, etc. But fundamentally, starting from what the student might be interested in and using the power of mathematics and computing and coding to be able to work out better answers to those questions. Now, when you talk about ethics and all these issues, they have a computational thinking way of approaching them. But you're not going to do it by solving, quadratic equations by hand or doing long division. It has nothing to do with that. You may solve it by using tool sets like machine learning. Why aren't we having machine learning in the curriculum for primary school children, for 10-year-olds? They can't make new neural networks, but they can use the idea of machine learning comes very, very naturally at a young age. There's no reason not to use it to solve problems. But we're not doing that. We're doodling around trying to pretend to be a computer from before when computers existed, when maths wasn't used for any of these subjects, and we didn't able to use computational thinking in that way. So one thing we've been doing is, we've got basically a full proposal, and a lot of the things Sue was talking about, for example, like exactly what should you do at each level. We have some very definite proposals on these things, born of 30 years of trying to get people around the world to compute more, so to speak, and across all different subjects. So we're sort of the world experts on knowing what people do with computation. And one of the places we've started is to say, let's look at the outcomes we really want from this core subject. I don't want to call it maths, because if you go and say, are we reforming maths, making a new subject? Is it coding? I don't really care what it's called. There's a core computational subject. We'll take some significant part of the curriculum that needs fundamental reform and hooking together with coding. That's where we need to get to. It's obviously it's an evolution to get there and some revolution. But to start with, you need to know, what are the outcomes you really want? And when you look at the outcomes from traditional maths, for example, it just doesn't match what students like Michaela need. And some of these questions have come up. So we've built an 11-dimensional outcome tree. You can find it on computerbasedmath.org/outcomes as a starting point for summarizing that. Things that you could measure, but are not defined by the exams. And then, we also tried to build actual modules, which are headed things like causal correlation. Are girls better at maths? Take a big data set. Can girls and boys have a different theory as to who's better at maths from that? For example, you look at the data set. What are you measuring? What are you asking? These sort of fuzzy questions that kick off computational thinking that we really need. That's what the world's like out there. We don't have, multiple choice questions to answer when you're running a business or working in the tech sector. You have fuzzy questions that you need to apply computational thinking with the power of AI and computing behind it. And that's what we need to get our students experience at. And it needs a very fundamental change to the curriculum. I mean, there's no way around it. Computing is great, what's got going in that, but I think we need to move forward from that.
Keep moving so we can make sure we're keeping other folks as well. Michaela, can I ask you a little bit about that sense of from your perspective, what you've thought about that? You've talked about that pre-professional view of education, what the world looks like in terms of the future of work, and what you think about that emerging relationship, which again, both Conrad and Sue have been talking about, between these very powerful systems. And of course, we're all excited about AlphaFold today. And one of those moments where you think, is this really one of those very big leaps forward? So what have you felt about what that future landscape looks like from the vantage point, and indeed how prepared you've been for it?
Mm-hmm. Well, to be completely honest, I think that the education system that we currently have in the United Kingdom and the world of artificial intelligence and tech that we're moving into are so disjointed and so far apart at the moment. I only truly came to understand and really explore the world of tech and AI after I graduated from school. When I was in school, I was still taught this same mindset that you as a person have to choose the type of student you are, whether that's humanities or science or arts, and you need to stick to that. You need to choose your GCSEs, and they need to have a sort of certain direction, and then with your A-levels you narrow it down even further. And so then we take a look at the world of artificial intelligence and tech, and we hear all these conversations about the need for interdisciplinary thinking. We hear about the need to have philosophers, to have ethicists, to have business people, to have the software engineers all working together to form this, this really collaborative environment for the future of ethical and positive tech. And yet that is not reflected in our school systems. And so what we're currently teaching students, yes, the curriculum is outdated, and yes, the hard skills we're teaching them is outdated, but equally important to me is what the way we're teaching students to think and the soft skills that we're preparing them with in the current system is outdated and doesn't coincide with what we want to see in the future of artificial intelligence and tech.
Thank you. Sue, your sense, I mean, it's again somebody who's been sort of in the trenches on the, you know, the realities of this. What's your sense around that future work landscape and the way in which the curriculum currently is or isn't preparing people for these different relationships, whether it's going to be careers in data scientists, awareness as a citizen about AI, data everywhere. What's your sense of how well that's going at the moment?
Well, I think if we talk about UK, it's difficult to talk about across the UK because Scotland, for example, has more of a competence-based curriculum, and England has a very knowledge-based curriculum, where I think we're talking about. So the emphasis is on, you know, foundations and facts and that sort of thing, and I think this is where Michaela's reflecting this disconnect. So I think part of it is, you know, good teaching, bringing in context, making things real. You know, we've got our Isaac Computer Science platform. We've got a big AI day for A-level computer science students to meet industry, you know, people from industry and learn all about it, and making those links all in sort of through school, and having the relationship between technology and industry and education, which really helps. I think that can help. But I think it would be a complete, I think what Michaela's talking about is this move away from separate subjects. It would be a huge change. I mean, I think AI is a very multidisciplinary subject. It would be a huge shake-up in order to, if we were, you know, looking at the relationships between subjects and how we, you know, work across them, because we do have a system where we teach subjects very discreetly. And I think that's what Michaela is saying, you know, didn't kind of give that connect and coherence when she was at school. It's a big issue to address, really, I think.
Thank you very much indeed. Right, we've got, I've been given the countdown, so we've got 5 minutes. So I have some rounding up thoughts here. We've got 4 minutes. And I'm going to come to Conrad first, and then Sue, and then Michaela, I'm going to come to you last. And it's kind of a question I just to very quickly, responsively, what would a great lesson look like? Conrad, you can choose your age group, whatever age group you're going to look like. So you've got them in a classroom.
Start with a problem that seems interesting, you know, and a broad problem. I mean, you know, as I mentioned, some of the ones we had, you know, cause or correlation, you know, is what is true on a particular thing. Try and use that apparently fuzzy problem and apply any kinds of thinking skills, including computational thinking, to get a good answer. You want to make decisions from those sorts of starts and not have very collimated, you know, where you're given an equation to solve and you go solve it. And I think that I just want to say one other thing, which is the urgency of this problem. Okay, this is, you know, we're seeing political problems around the world from people not understanding data science, having data literacy, or more generally computational literacy. And I think we have a bigger opportunity as with mass literacy. I see this as an opportunity for mass computational literacy. Britain was early in leading the world to idea of mass literacy in the 19th century. We need to do the same now for computational literacy, and we can.
Super, Conrad. That's a great answer, and I like that emphasis on solve a problem. Sue, same question. You've got a class. What's a great lesson look like?
I think you need to start with a context. So you pick something that is current. You look at something that's live in, you know, healthcare or in the environment, or something that means something to young people, and then you use that to look at what the issues are and how the topic that you're learning can apply to those issues. And I think we can still cover the sort of the core foundations and the programming principles and the knowledge and the knowledge representation we want to put into the curriculum, but contextualizing them, I think, makes a great lesson and makes it make sense to students.
Thank you, Sue. Michaela, for you to wrap up, and then I'll just do the hand back. So
Yeah.
Same question to you. What does a great lesson look like?
So it would be a year 7 or 8 class before, we're into the GCSE mindset where we're trying to engage them. And it's challenge-based problem solving. We give them a real-world challenge, whether it's climate change, whether it's poverty, whether it's anything like that. And we say, right, artificial intelligence is going to be key to solving this. We need you to think. We need to have someone who's thinking about the ethical side of things, someone who's thinking about the business side of things, and then some students who are thinking about how are we going to use coding and how are we going to use artificial intelligence and machine learning algorithms to solve it. More hypothetical conversations before we then move into the GCSEs, where they then teach you those fundamental computational skills.
Fantastic. Well, thank you very much indeed. That was, gosh, you all kept the time so great. We've covered a lot of ground very quickly, so I'm really very, very grateful to you all. And I think this emphasis on what I heard you all say was make it a piece of real world problem solving, which people can then, bring a series of multidisciplinary skills appropriate to the age. So I think we're nearly done. And I think I'm able to say back over to you, Joy, and I hope you all enjoy the rest of the day. And thank you to my panel very much indeed. That's been terrific, and we covered a lot of ground in a very short amount of time, and I'm very grateful.